Good morning. Let's talk about unions of events. A union, when we're talking about probabilities, means perhaps the union of A, which would be the probability of A union B, means that it is in either A or B, or it can be both. So here's A, here's B, here's both. Now, if we say that the probability of A union B is the probability of A plus the probability of B, then that means we take this, the probability of A, well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 things that are in A. And the probability of B, well, let's see, how many are in B? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 9 plus 12 would be 21. But are there 21 things here? We've only got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that's just 1, 12, 13, 14, 15, 16, 17. Try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. How did we get 21? Well, the problem is that these 4 that are in the intersection got counted both times. They're in A, check, but they're also in B, and so they got counted both times. So because of that, we have to subtract the probability that something is in both A and B, which is their intersection. We write the intersection like this. So this is A intersect B right here. So there's 4 there. By subtracting them, we're not taking the whole thing out. We're taking out the fact that it got counted twice. So we're only subtracting it once. And 21 minus 4, sure enough, is 17. Now, if A and B are what they call mutually exclusive, if they have nothing in common, if they do not overlap, then A union B, let me say the probability of A union B would be the probability of A plus the probability of B. Because the probability that it could be in both, by definition, if they have nothing in common, would be 0. So let's see if we can try out an example here. Suppose your windshield wipers are not working. Oh my. The probability that you need a new motor, they say, is 55%. Over half the time, that means you got to have a new motor. The probability that the switch is 0.4, which would be 40% of the time, you need a switch. It's possible that you might need both. That probability is 15%. What is the probability that it's neither one of these? Maybe it's just a loose wire. Okay, let's say the probability, let's use letters that'll let us remember what's what. So I'm going to use M for motor and S for switch. So neither would be the union. No, A and B would be both. So we're looking for not A and B. What we want to do is find not either A or B. We want to find not A or B. So basically, we're looking at this. Here's A. Here's B. They obviously overlap. The probability of A is 0.55. The probability of B is 0.40. And the probability of both, the intersection here, is 0.15. Now notice that this adds up to more than 100%. If you add this and this and this. But the probability for the union, what we're looking for is neither. So we're actually looking for this out here. Right? Fix yourself. So what we want to do is take the union of A and B and then subtract that from 1 to see what's left. Okay, so let's just back up from this and do this one piece at a time. We know what we need now that we got a picture to look at. Okay, so we need to find the union and subtract it from 1. We're going to do 1 minus the union. Well, here's the union. This whole thing, we'll take A, we'll take B. This 55 represents this entire circle. So it's going to be 1 minus the probability of A plus the probability of B minus the probability of their intersection. Which is going to be 1 minus the probability of A, was 55, oh, I got it over here. So 0.55 plus 0.40 minus the twice counted 0.15. So 1 minus, this is going to be 95 minus 15 leaves 80. Which is 0.2 or 0.20. And this is what we're looking for. The probability that was one or the other was 0.80, 80%. So the probability is not either one of those is 0.20.